Today we will discuss cleaning principle. Now, cleaning methods of cotton could be chemical cleaning, mechanical cleaning, and also washing. But in this course, we will be mainly focusing on mechanical cleaning. Mechanical cleaning has two aspects. One is liberation and the other one is separation. Liberation means liberation of trash particles, and separation means after liberation how to take them out. So, that is the separation part. So, cleaning has always two aspects, liberation of trash particle, and this should be immediately followed by separation of trash particles, and both should be highly effective and appropriate to the nature of trash that we have in cotton. Now, mechanism of trash liberation. What are the various mechanisms which are employed in the machines? These are listed here. One is through loss of kinetic energy. The other one is impulse through beating actions. The loss of energy is through scrubbing action. The third is centrifugal force, application of centrifugal force, and the fourth is through application of pneumatic force. These are the four different mechanisms which are working in the machines that have been designed for the mechanism of trash liberation. Now, we will discuss them one by one. First, loss of kinetic energy. If we look at this slide, what we do it here? See, here in this diagram there are certain triangular bars, we call them grid bars. They are triangular iron bars, and there a cross sectional view is shown here, and they have a length. So, they go across the full width of the machine, and they are arranged in a sequence the way it is shown at the bottom of any cleaner or beater. Fiber tufts with impurities on its surface, as shown here a tuft, are guided over stationary triangular grid bars, mote knives, etc. What is mote knife? You will come to know as we go through the course, at very high speed. So, these tufts are made to pass, and here is a tuft, and these dark dots are representing the trash on its surface. So, the tufts are made to pass over this series of grid bars at a very high speed, and the pointed edge is acting against their path. As a result, what will happen? There will be a series of impacts between the trash particles and the grid bars. Grid bars are stationary. The tufts are moving at a high speed. The surface is full of trash, and as they cross over this zone, there are repeated minor impacts. What is happening? The kinetic energy of the trash particle after impacts with the metal surface is immediately dissipated, because once there is an impact, the speed of the trash particle will be almost 0, and therefore, there will be loss of kinetic energy of the trash particles because of this impact. and this energy will be the cause for trash particles to be liberated from the surface of the tufts. Since these bars are large and equal but opposite reaction force will act on the particles, which will dislodge the particles from the fiber. So, this basically an impulse force or impact force is going to act on these trash particles, because once there is an impact their velocity will be 0 and the opposite reaction force is going to act on them and they will be dislodged. The particles will mostly fall down due to gravity action as shown here. They will escape through these grid bars. So, the number of impacts depends upon the number of grid bars that we keep in their path. If we have more number of grid bars, there will be more number of impacts. So, this is the action is also known as scrubbing action, but the mechanism which is active here is basically a loss of kinetic energy or an impulse. Okay. The next one is actually impulse through beating action. Now, you will come to know about, we have discussed about the beating action earlier while discussing the opening of tufts. So, what happens in the beating actions? The flocks or the tufts are fed slowly by a feed roller and they are subjected to strong blows by the fast moving beater blades or strikers which are there on their surface. In this case, these are the strikers. So, they are coming and they are hitting the tufts which are being fed by this pair of feed roller. So, what will happen? The velocity of the tufts will change instantly within microsecond. The speed of the beater could be 500, 600, 800 RPM, anything between 400 to 800 RPM, and we can find out what velocity is there at the level of the strikers. So, there is a sudden change in velocity of the tuft and also of the trash particles, and this impulse is going to liberate the trash particles. The impulse magnitude is m v I minus v f, where m is the mass of the tufts or it could be the mass of the trash particle, v I the initial velocity which is the velocity of the feed roller pair through which we are feeding the tufts, and v f is the final velocity, that is the surface speed of the beater at the top of the strikers, top or tip of the strikers. So, there is a sudden change in momentum, and this momentum change is happening in microseconds. We can easily find out. If I give an example, suppose a beater is rotating at a speed of, let us say 600 RPM. Okay. So, 600 revolution per minute. Now, per second it means speed is 100 revolution. Now, if there are, let us say 3 beater blades in it, that means in 1 second how many beating is going to take place? 100 into 3, 300 beatings will be happening. So, in 1 second the tufts which are being fed, they will be receiving 300 blows, and therefore, how much time goes in receiving one blow, that is 1 upon 300 second, which is how much is 1 upon 300? 1 upon 300 is going to be 0.33 into 10 to the power minus 2 second. So, it is a very, very small this timing, and therefore, there will be almost instant change in velocity, and this impulse is going to be almost, this is going to be inelastic impulse. So, this change in momentum and kinetic energy will cause liberation of the impurities. This is another way that the trash particles can be liberated. Now, we go to the next one, which is centrifugal force. This is also active in many designs. Now, this, see, look at this one, which is a rotating cylinder or a drum, whatever you call it, and on the surface we have some spikes, could be some striking elements, it could be saw teeth, whatever it is. So, the trash mixed flocks resting on the strikers or saw tooth or blades of a rotating device are subjected to very high centrifugal force. So, if there is a tuft or fibers over here, they will be subjected to very high centrifugal force, and as a result the particles will be ejected, because their attachment force to the striking element is very, very low, whereas the attachment force of the tuft with the striking elements is much stronger in comparison to the trash particles. Hence, trash particles will easily get ejected, and tufts are going to be held back because of their strong attachment with the strikers. And the magnitude of the centrifugal force is stated here, which you all know, you have learnt in basic physics, which is m r omega square or m v square by r. And since you see that the centrifugal force is proportional to omega square, therefore, if you plot C f versus omega, we will get a non-linear curve. That means, with the increase in omega, C f will rise very fast. Okay. The next force which is acting is a pneumatic force. This also is present in some of the machines, and this is also effective in liberating trash particles. Like the flocks along with the liberated trash particles are directed towards a moving perforated screen. Like in this diagram, this circle that you see is a perforated cylinder, and from the other side, from the left hand side, we are feeding tuft and trash particles. So, it is a mixture of trapped and trash particles are being fed. So, and air is being sucked through the perforations of these cylinders as shown in this diagram. So, what will happen? The particles are sucked away through the perforations, while the fibers remain on the surface, because the fiber tufts are larger in size in comparison to the size of the perforations. So, they will remain on the surface of the cylinder, and the trash particles will move inside, and it will be a dust laden air which will be sucked out from this drum, and the tuft will be staying on the surface of the perforated cylinder, and then they will move along in the cylinder, and they will be finally they will be dropping at some other place. So, what forces are acting here? It is the air drag force on the trash particles adhering on a fiber would be F, which is half C A rho V square. That is, when a particle is resting, a trash particle is resting on a fiber, and let us say the fiber is resting on the perforated drum, then the trash particles will be subjected to the drag force, which is equal to half C A rho V square, and where C is the drag coefficient, A is the projected area of the trash in the direction of the airflow, rho is the air density, and V is the boundary layer air velocity. So, this force could be sometimes or many times could be very high in magnitude and can easily dislodge a particle which is sitting on a fiber. Once it is dislodged, it will be sucked. So, this is another way through which we can liberate the particles from the flocks or from the fibers. As I said, as you have shown in a slide, that liberation should be followed by separations. So, sometimes we liberate particles, but they still remain mixed with the fibers. In that case, even after liberation, there is a possibility of remixing of the trash particles with the fibers again. So, liberation not necessarily will lead to separation of the trash particles from fibers. So, we have to have a means to separate out the trash particles from the fibers once they are liberated from the fibers. So, the separation mechanisms are: one is buoyancy difference, number 2 is combing action, number 3 is centrifugal separations, and number 4 is gravity separations. So, these are the 4 different ways by which liberated trash particles are separated from the flocks or from the fibers, and we will now discuss them one after another. So, we first go to the separation by buoyancy difference. Now, here what we do, the buoyancy of trash particles on the fibers are different from each other. This is what is known to us, the trash particles buoyancy and the buoyancy of the fibers in the flock form. In the flock form, they are quite voluminous in nature, while the trash particles are much more condensed. Their density is quite high in comparison to density of the tuft or the flock. So, there is a difference between them, and this differences in buoyancy can be used for separation of trash from fibers. What we do? We can think of like this: mixture of tufts and trash particles are directed downwards, like here trash and tufts are moving forward, they are directed downwards as shown in the diagram, and a stream of air flows and cross the path horizontally. This is also shown in this diagram. So, tufts and the mixture of tufts and the trash particles falling down, and we are directing the airflow towards them. What happens? The fibers and the trash particles follow different trajectories. The trajectory of the particles and the tufts are shown here. You see, the dark circles are representing the trash trajectory. They are the trash, and the hatched line is representing their trash trajectory and the tufts are on the right hand side. So, this is the tuft trajectory. So, trajectory of the tuft and trajectory of the trash particles will be different. Once there is a cross flow of air and because the trajectories are different, so they will destinations will be different now. Air drag on trash particles will be less and they will fall vertically downwards due to gravity actions. Okay. So, they will all fall mostly downwards, whereas flocks being lighter and voluminous, they will be carried forward due to high drag force. That is what is going to happen. As a result, the fibers will be separated from the trash particles. So, fibers in the form of tufts will move towards the right hand side, whereas the trash particles are going to fall down and therefore, we can collect the trash particles and allow the tufts to move forward. So, this principle can be used for separating trash from fibers. The other one is this separation by centrifugal force. Centrifugal force we have seen earlier, it can liberate and this also can help us in separation as well. The high centrifugal force acting on the dust or trash particles while it follows a circular path along with flocks and tufts can cause the particle to be liberated due to high centrifugal accelerations. So, here the trash particles will be liberated, which we have discussed earlier, whereas the tufts will be retained mostly by the striking elements. The liberatable particles could now be either trapped or they can be ejected, they will be allowed to move out. So, this principle also used in some of the machines. So, in this case the drum is there on the top of the drum surface, there are a lot of striking elements and it rotates. So, therefore, the flocks and the trash particles are following a circular path and hence they will be experiencing centrifugal force as per the formula given here. Or we can what we can do, we can make the path of air as well as trash particles in this particular diagram, in the lower diagram, they can their path is such that they follow a curved path. So, there is a curvature in their path, it is not a straight path. So, if we have a curvature, then also you see that a centrifugal acceleration will be acting on the trash particles and the tuft. So, trash particles will not be able to follow the bend and they will be, if we keep an opening over here as shown this place, the particles will most likely follow a straight path and will be therefore, they will be moving out and they will be collected at the bottom. So, there is a escape route for the trash particles, because if we force them to follow a curved path, trash particles will not be able to follow the curved path in comparison to the tufts, where tufts can easily follow the path because they are lighter, whereas for the trash particles it will be difficult. And if we keep an opening and place it strategically, then we will find lot of trash particles to get ejected through that opening. The other separation method is separation by combing actions. This is something which is very common, and we are also familiar with these combing actions. All of us always use a comb to comb our hair, and if there are some particles in our hair, we see that if we run the comb through the hair, lot of particles get caught in between the spaces of the needles. The same thing, the same phenomena also happens here. When a comb with dense set of needles is passed through a mat of fibers, the impurities are trapped in between the needle spaces, and therefore, they are dislodged and extracted from the inner part of the tuft. This is what can also be used, and this is also done in some machines. The other one is the gravity separations, which is also very common. So, we have seen that the impulse earlier has liberated a lot of particles, and now the liberated trace particles and the flocks are hurled over the grid bars. See here, as you see in this diagram, there are grid bars over here. So, a tuft as well as the liberated trace particles are made to pass over this series of grid bars, and what happens? Being small in size, the impurities pass between the grid bar spaces due to gravity and get collected in the waste box, which is below, or they may be sucked away, whatever we want. So, here these trace particles that we see here shown in this diagram, they are falling down because of gravity actions, because comparatively their weight is more in comparison to their size. So, they will easily fall down, while the tufts are very lighter, and they will not be able to pass through the narrow gaps that we have kept between the grid bars. So, grid bar spaces are large enough to allow the trace particles to fall down, whereas they are small for the tufts to fall down. So, mostly tufts will be moving over the grid bars, whereas trace particles will be falling down, and this is the way we can also separate out the trace particles from the fibers. Okay. Now, we will discuss this point, that is how to increase the intensity of trace liberations. So, we have understood that there are two mechanisms which is important for cleaning: liberation and separations. So, liberations, the forces are centrifugal force, impulse, pneumatic force, the scrubbing force, which is basically also a kind of is not a basically this is a loss of kinetic energy. So, if we centrifugal force, if we want to change the intensity of this force, what we can do, as we know from the formula, centrifugal force is m r omega squared. So, what we can do here, if we want to increase the force, the rotational speed of the opening element can be raised, diameter of the drum or the roller can be made larger, velocity of the airflow can be increased, or radius of curvature of the bend in the duct can be increased. So, these are the ways by which we will be able to increase the magnitude of centrifugal force. Impulse, also speed of the beater or diameter of the beater along with the strikers, that is the tip of the strikers, and the setting between the feed nip to the line of action of the opening elements. This setting is also very important for the impulse. The other phenomena is pneumatic force which depends upon the suction fan speed is the velocity of the air flow. So, velocity of the air flow depends upon the discharge rate of the suction fan, which in turn depends upon the rotational speed of the suction pump, suction fan, and the scrubbing force or the scrubbing action better is depends upon the sharpness of the grid bar edge, their angle of inclinations, the closeness of the interacting surfaces, that is the tip of the striking element and the grid bars. Between these, the space which is there, that will also decide the intensity of the scrubbing force which is acting on the tufts. So, these are the means by which we can change the intensity of the trash liberations, but we have to understand that the intensity should not be increased to a level where the fibers get damaged. So, we have to also keep in mind that fibers should never get damaged, or if at all they get damaged, there should be as minimum as possible. And the intensity of the separation, if we want to improve, what we can do? One is gravity separation. If we think of, then what matters is the size of the slot, that is the space between the grid bars. The setting between the grid bars, the setting between the grid bars is the distance, the space between the grid bars. The size of the slot is in the case of where there is a bend. So, there the slot matters, like in the case of that if we make the tufts to follow a curved path and we have to have an opening in that curved path. So, that is which are calling the slot. So, size of the slot, how big is the slide of the slot, that also matters. If we increase the size, more trash will pass through, but none of the systems is never 100% efficient. So, even though more trash will pass, as you open it out, if you increase the size of the slot, some fibers will be able to pass through that. Hence, there is a limit to which we can increase the size of this slot. So, this slot size in respect to a situation where the fibers or the tufts and the trash particles are made to pass or made to move in a curved path. Then the speed over the grid bars, that is the speed at which the particles are hurled over the grid bar, that also will matter. So, gravity actions, this can be depends upon these factors. The other factors could be the angle at which the grid bars are placed also. So, that also can matter. The other thing is the suction rate, where the size of the screen perforations. So, where we are using a perforated screen or a perforated drum, the size of the screen will also, perforations of the size of these perforations also will matter. The other thing is the discharge rate, that is the rate of suction through this suction drum. And the other thing which can also be important here is the rotational speed of the screen or the perforated drum. That also can have some influence on the separation efficiency, trash separation efficiency. The buoyancy is in the case of buoyancy, what matters is the velocity of the crosshair, what velocity the crosshair is moving. A very high velocity is not going to be beneficial, and so there has to be some control on the velocity of this crosshair, and the location of the separation edge. Also, we will find that in some cases when there are two types of trajectories are there, as we have discussed, trajectory of the trash particles and the trajectory of the flocks. Now, we have to have a separation edge which will distinguish between these two trajectories. So, the separation edge has to be placed in such a location, so that most of the trash particles remains on the left hand side of the edge, and the trajectories of the flocks remains on the right hand side of the edge. Sometimes there is no clear cut boundary, and therefore, the separation edge location needs to be adjusted, so that we can improve the buoyancy separations. So, these are the techniques which we use, and they can be influenced. The next point is the removal of dust. Dust are very fine particles. So, whatever we have discussed till now, these techniques are not suitable for removing very fine dust particles. They are very micro dust, are very small in size. So, dust removal is really difficult, because dust particles are lighter than fiber and they have a strong adherence with the fibers. So, they can be liberated by vigorous fiber to metal friction and fiber to fiber friction. So, you should remember that when there is a very strong fiber to metal friction, or wherever there is a fiber to fiber friction, these particles will be liberated, the fine dust particles will be liberated. So, we have some machines where the fiber to metal friction or fiber to fiber friction is very intense, and in those machines the dust particles, lot of dust particles will be liberated, and we can remove them. So, after liberation, the dust can be sucked away by controlled suction. So, in the blow room machines, there is always a mechanical action going on between the tufts and the many different types of mechanical elements. So, lot of dust also is liberated here, and we try to suck away those dust, but even then we will find that beyond the blow room still some dust are still left in the tufts, and therefore, what we do that once we go beyond blow room machines, there are some machines like carding machines, like draw frame machines, which you will learn. In those machines also we try to suck out the dust particles. So, the dust removal is initiated in blow room, but the dust removal is not complete in blow room, it goes on. With that, we close this particular chapter, and thank you.